Open your eyes. What kind of world do we know today? A world of skyscrapers, airplanes, the internet, satellites, and massive cities glowing across the planet at night. A world where humans see themselves as the dominant species on Earth. But none of this had to exist. 66 million years ago, an asteroid roughly 10 kilometers wide was heading toward Earth. But what if its path had changed, just slightly? What if it missed by only a few thousand kilometers and passed us by? In our reality, that impact became the end of an entire world. A monstrous explosion, global fires, giant tsunami, dust blocking out the sky, and a sudden cooling that wiped out the world that came before us. But what if it never happened? What if the world of dinosaurs was never erased? What if dinosaurs continued to rule the planet while humans remained small creatures, hiding in the dark? Hours passed, then days, but the end of the world never came. The sky remained bright, the forests kept rustling, and the dinosaurs carried on as if nothing had happened. The world never even realized how close it had come to extinction, and while in our reality, the age of mammals was beginning. In this version of history, Earth remained much as it had always been. Earth remained a world of dinosaurs. 1,000 years passed. For Earth, it was barely a moment. Across the lands that would one day become Montana, the Dakotas, and Wyoming, warm plains, swampy forests, and broad river valleys still stretched across the landscape. Here, life carried on as usual. Along the rivers, Edmontosaurs gathered, grinding through tough vegetation with their broad beaks. Out on the open plains, Triceratops moved in groups, massive social animals that may have challenged one another for space, status, and the right to reproduce. Through the dense vegetation, massive ankylosaurs moved slowly, armored dinosaurs with no need to hurry. And through the forests and river valleys, tyrannosaurs hunted, among the largest land predators of the late Cretaceous, still standing at the top of the food chain. But look lower, beneath the roots, inside the burrows, and through the grass at night, and an entirely different world appears. The world of mammals. They looked nothing like the lions, wolves, or apes that would appear much later. Most were small creatures. Among them were multituberculates, a successful group of mammals with strong teeth, well adapted for processing tough food. And early eutherians, members of the distant branch that would eventually give rise to placental mammals, including humans. They lived cautiously. They came out mostly at night. They hid from predators. They fed on insects, eggs, fruit, and anything else they could find. In our history, these animals were given room to expand after the catastrophe. But here, there was no catastrophe. The dinosaurs never disappeared. The ecosystem never opened up. 1,000 years had passed, and the world had barely changed. But evolution does not work in days or centuries. 1,000,000 years passed. By then, the world had already begun to change. Across what would one day become India, the Deccan Traps were still erupting. This was not a single volcano, but a vast volcanic region where lava repeatedly flooded entire landscapes. Along with the lava, carbon dioxide and sulfur compounds entered the atmosphere. Sulfur emissions could trigger short periods of cooling, lowering average temperatures by around 5 degrees. Carbon dioxide, on the other hand, could drive longer-lasting warming. Changes in temperature and rainfall affected plants, and with them, the herbivores and predators that depended on them. Across the plains, the animals moving through this world may no longer have been the Edmontosaurs we know from fossils, but new species of hadrosaurs. In one study, hadrosaurs showed the weakest decline in diversity among the major dinosaur groups examined before the asteroid impact. So their descendants would likely have continued spreading and occupying new territories. But scientists still debate whether dinosaurs were truly in decline. Some researchers argue that certain groups were already losing diversity before the catastrophe. Others argued that this may simply be an illusion, created by an incomplete fossil record. Paleontologist Joe Bonser described the situation this way.
Dinosaurs were still dominant, still widespread, and still occupying the major ecological niches.
So the most likely scenario is this. After 1 million years, Earth would still have been home to many large dinosaurs, even if the exact species had already begun to change. At the top of the food chain, tyrannosaurids may still have remained. In some regions, Tyrannosaurus rex may have survived. In others, it may already have been replaced by close descendants. Exactly what they would have become is impossible to know. But evolution could have changed the length of their legs, their body mass, the shape of their skulls, and the power of their bite. In more open landscapes, natural selection may have favored lighter, more agile animals. Where large prey remained abundant, heavier forms, with massive skulls and powerful jaws, may have had the advantage. But what was happening to the mammals? Even before the asteroid impact, mammals were far more diverse than many people imagine. Some lived in trees, others dug burrows, some fed on plants, insects, or small animals. One of them was Didelphodon, one of the largest mammals in North America at the time. It reached the size of a small badger, had powerful jaws, and may have fed on mollusks, eggs, carrion, and small vertebrates. Shoalteria belonged to another group of relatively large mammals. Judging by its teeth, it was adapted for plant food, and possibly partly for digging, but neither of these animals was a direct ancestor of humans. Closer to the future human line were early eutherians, members of the larger branch that would later give rise to placental mammals, including primates and humans. All of this shows that mammals were not simply tiny insect eaters anymore, but most of them still remained small. The large land rolls were still occupied by dinosaurs. Multi-ton herbivores lived across the plains, while theropods filled the role of large predators. After 1 million years, Earth was still a planet of dinosaurs, but it was no longer a frozen world. The climate was changing, old species were disappearing, new ones were taking their place. And the more time passed, the further this Earth drifted away from our own history. 10 million years passed. Tyrannosaurs, Triceratops, and Edmontosaurs were now part of the past. In their place came new species, descended from the same great groups. Around this time, Earth went through another major climate shock. About 56 million years ago, a huge amount of carbon entered the atmosphere and the oceans. The planet's average temperature rose by about 5 degrees, and the warming lasted for roughly 200,000 years. One possible cause was volcanic activity in the North Atlantic, where magma heated carbon-rich rocks, releasing greenhouse gases. These processes did not depend on the asteroid, so similar warming could have happened in this alternate world as well. Warm forests spread farther toward the poles. Some regions became wetter, others faced long periods of drought. Animals migrated, following food and the climates they could survive in. And this raises a question. What happened to the giants and to the incredible size of the dinosaurs? Research suggests that body size depended not only on temperature, but also on food supply, competition, and lifestyle. In fertile valleys, large herbivores could still weigh tens of tons. A massive body protected them from most predators and helped them process enormous amounts of vegetation. In dry regions, smaller species had the advantage. They needed less food and less water. So on the same planet, giants weighing tens of tons could exist alongside distant relatives the size of a large dog. Horned dinosaurs may have changed, especially dramatically. The descendants of ceratopsians would have looked very different from triceratops. In some regions, massive forms appeared, with heavy skulls and long horns. In others, lighter species evolved, where horns and frills were used not only for defense, but also for recognizing others, displaying status, and attracting mates. But the underwater world changed even more. In the seas, descendants of ammonites, plesiosaurs, and mosasaurs may have survived. They were giant marine lizards, some more than 10 meters long, standing at the top of ocean food chains. After 10 million years, the familiar mosasaur species would have vanished, but their descendants could have split into new forms. The warming became a serious test for them. Some marine species died out, the oceans became warmer and more acidic, and in some deep regions, oxygen levels began to fall. In the sky, the competition between birds and pterosaurs continued. By the end of the Cretaceous, some pterosaurs had already become giants, with wingspans of around 10 meters. They may have kept control over open plains, coastlines, and places with strong air currents. But alongside them, birds were evolving as well. Birds were not just neighbors of dinosaurs, they were one branch of feathered theropods. In simple terms, they are the only surviving members of that dinosaur line still living today. Small birds reproduced faster, maneuvered more easily between trees, and could occupy niches that giant flyers could not reach. So the sky was likely divided between two worlds: large pterosaurs over open spaces, and birds becoming more diverse in forests, along rivers, and near coastlines. Mammals changed noticeably too. They explored tree canopies, water, underground shelters, and the night. Some reached the size of a fox, a badger, or a small dog. In dense forests, some mammals may have developed stronger grasping limbs, forward-facing eyes, and better visual memory. These traits helped them move between branches, find fruit, and catch insects. And here, another question appears. Did dinosaurs or mammals become noticeably smarter? Most likely, both groups developed more complex behavior, but in different ways. Small feathered theropods could improve their vision, coordination, and signals. Mammals could improve memory, learning, parental care, and the ability to adapt to new food. But a more complex brain required a lot of energy. It only became fixed by evolution when it gave a real advantage. So, for now, the question of intelligence remained open. After 10 million years, Earth was no longer a world of familiar dinosaurs. It was a new planet, with different species, different seas, and different ecosystems. And still, this was only the beginning. 30 million years had passed since the disaster that never happened, almost halfway to our own time. By now, it was not only life that had changed. The planet's climate was changing too. Earth was slowly moving away from a hot world toward a cooler one. In our reality, this was around the time of one of the greatest cooling events of the last tens of millions of years. Antarctica was becoming more isolated from the other continents. Cold ocean currents began to move more freely around it. The continent gradually became trapped in icy isolation and began to freeze over. And in many regions, warm forests began giving way to more open, seasonal landscapes. For animals, this meant one thing: the old ways of survival no longer always worked. In a world where the climate was shifting, forests were retreating, and familiar food sources were disappearing, evolution began to work not only on the body, but also on the brain. And here, birds become especially important, the direct descendants of theropod dinosaurs. Modern crows can remember faces, solve problems, and use objects as tools. Parrots can learn sounds, recognize shapes, and build complex communication. This does not mean ancient dinosaurs would inevitably have become second crows, but it shows something important. The dinosaur line already had a path toward more complex brains. Imagine small, predatory reptiles, about the size of a wolf or a large dog. These predators were no longer simply rushing at prey. Over time, they could remember where herbivores most often came to drink. They could tell weak and young animals apart from healthy adults. They could use calls and body movements as signals for the group. This kind of hunting required more than teeth and claws. It required memory, observation, and learning. In herd-living dinosaurs, intelligence could have developed in a very different way. The descendants of horned forms may no longer have gathered only for protection. Their herds could have become complex communities, where different individuals played different roles. Some were better at noticing predators from far away. Others remembered where water remained after a drought. Over time, such groups may have become more than crowds of animals. They could have become clans where experience mattered. They could learn routes, alarm signals, defensive behavior, and even how to react to different predators. This would not have been intelligence in the human sense, but their behavior could have become more complex than that of their distant ancestors. And that may have been the greatest difference after 30 million years. Dinosaurs were no longer only changing the shape of skulls, horns, or armor. Evolution was no longer selecting only for stronger bodies. It was also selecting for those that understood the world around them better. And what about the mammals? In dense forests, small tree-dwelling forms may have existed, distantly similar to future primates. Grasping limbs gave them better control while moving through trees. Memory helped them find food in places where it appeared only at certain times of year. In our reality, traits like these eventually became part of the path toward primates. But here, that path was far more dangerous. Large dinosaurs still moved beneath the trees. Predatory birds and pterosaurs may have circled above. Semi-aquatic forms could use riverbanks as shelter, diving when threatened, hiding food among tree roots, and building complex tunnels near the water. Underground species could create whole systems of shelters with multiple exits, not just burrows, but safe networks. So for these mammals, intelligence was not a way to become dominant. It was a way not to disappear. There were still about 36 million years left before our own time. And during this final stretch, the alternate Earth may have changed more than ever. Because now, we are approaching the main question. What would the world look like today if dinosaurs had never disappeared? Present day, 66 million years had passed. If you looked at this Earth from space, it might seem almost familiar. Nightlights, roads, ports, cities along rivers, traces of industry, perhaps even satellites in orbit, but none of it was built by humans. Paleontologists have already wondered whether a dinosaur could have become intelligent. Back in the 20th century, Dale Russell proposed the image of a dinosauroid, an intelligent descendant of a small predatory dinosaur. But today, that idea is often criticized, not because an intelligent dinosaur was impossible, but because it did not have to look like a human. If intelligence had appeared in dinosaurs, it would have grown out of a different body. Not the body of an ape, but the body of a fast, two-legged predator. Imagine a creature roughly human-sized or slightly taller, light, lean, with long hind legs, a tail for balance, and a flexible neck. Its body could have been partly covered in feathers or short down. Its front limbs would not have been human hands, but they may have had mobile, clawed fingers, capable of holding objects, shaping bone, wood, stone, and later, metal. Their first settlements may not have grown around fields, as human settlements did. They may have grown around water, nesting grounds, hunting routes, and protected high ground. Their cities could have been built in terraces, wide stone platforms, sloped passages instead of stairs, tall observation towers, protected nesting districts, and separate spaces for the young. Their technology may not have developed exactly like ours, but it could have climbed similar steps. Control of fire, shaping stone, weapons for hunting and conflict, ceramics, metal, transport, states, industry. And if such a civilization appeared even a few thousand years before humans, that alone would have been enough to change everything. But if it had a 66 million year head start, by the present day, the planet could already have been fully claimed. Because an intelligent species does not simply survive in nature, it begins to rewrite nature around itself. But where would humans be in this world? Most likely, humans as we know them would not exist at all. Steve Brusatte and other paleontologists often point to a simple idea.
Without the extinction of the dinosaurs, our ancestors probably would not have received the chance they received in real history.
Humans may have appeared. They may have learned to speak. They may have lit a fire. They may have looked up at the sky. But someone else would have reached the summit first. The planet had already been divided. The rivers, the plains, the coasts, the roads, the cities. All of it was controlled by another intelligent species. And perhaps the main reason we call ourselves the dominant species today is not that humans were inevitable, but that one day, a 10-kilometer asteroid did not pass us by.